Today we're going to learn about solving quadratics by factoring. In order to solve quadratics by factoring, we do need to remember the steps of factoring. The first step when we factor is always to factor out a GCF. After that, you can look into a few different options. We want to see, is it a special case? Can we apply the difference of squares? It'll be a lot quicker that way. Is A equal to 1? Can we use our shortcut? If we can't do any of those, then we have to rely on our factoring by grouping. The guideline steps to solving quadratics by factoring are pretty simple. The first step is to set the equation equal to 0. Then we go through our factoring process. We use something called the zero product property to solve. The zero product property allows us to set each factor equal to 0. The zero product property states that if A times B, a product, is equal to 0, then either the first part of the product or the second part of the product has to be equal to 0. This is a property that allows us to solve quadratic equations by factoring. Through this property, you'll be able to find multiple answers to your quadratic equations. Here's example 1. It's already set equal to 0, so we don't have to do any work there. Our GCF is 2, so we will start by factoring a 2 out front and rewriting our equation in this way. After rewriting the equation with the GCF factored out, I notice that A is equal to 1, which is exciting because that means I can use our shortcut and only look for factors that multiply to 6 and add to 5. The factors that do that are positive 3 and positive 2. And I can quickly write my factored form to be x plus 3 times x plus 2 is equal to 0. That factoring should really be a review for you at this point. The new thing today is solving. We have an equal sign, we have an equal to 0, which means that we could say each factor here is equal to 0 could result in a solution to our equation. The first equation we get using this property is 2 is equal to 0. There's no x there. There's no way to solve for x there. 2 is not equal to 0. So it's actually pretty useless, honestly. We have x plus 3 is equal to 0 as our next factor. To isolate x, we would subtract 3 from both sides. We get x is equal to negative 3. X plus 2 is our last factor. Set that equal to 0. Subtract 2 on both sides. We find that x is equal to negative 2. Now, proper math notation does ask us to write our answers in curly bracket from least to greatest. However, we're really looking for the skill here. So if you can get our two solutions and somewhere on the paper, circle them, maybe to be nice, we'll give you full credit for that, even if you don't use your curly brackets. Example 2 is not set equal to 0 from the start. I like to keep my x squared positive, so I'm going to move 9x to the left-hand side of the equation by subtracting 9x. Rewriting my equation as 3x squared minus 9x is equal to 0. I do notice a GCF of 3x, so I'm going to take a minute and factor that out, resulting in 3x times x minus 3 equals 0. I notice I can't factor that anymore, so that's one of the nice ones where the GCF is the only factoring you have to do. My zero product property says set each factor equal to 0, and your GCF does count as a factor, whether it has a variable or not. This GCF has a variable. We have 3x equals 0 that has a solution because it has a variable. So we get that x is equal to 0. Remember, 0 divided by a number is okay. It's something that can happen. It is 0. And then we get x minus 3 is equal to 0. Add 3 on both sides, getting our second solution of x is equal to 3. For the sake of our notes, curly bracket notation, x is equal to 0 and 3. Number 3 is looking a little bit more complicated. Hopefully when I do some math to set it equal to 0, it is a bit nicer. Again, I like to keep my x squared term positive, and I notice that in order to do that, I have to move this 2x squared to the other side by adding it. So I'm going to move all of my terms to the left-hand side. Subtract 5x. I'm going to subtract 69, resulting in 4x squared minus 169. My GCF for this is 1. Not helpful, but always worth a look. Might make it easier for you. I noticed that this can be written in the form a squared minus b squared, so I'm going to apply the special case of difference of squares. In order to write this as a squared minus b squared, I'm going to say that 4x squared is equal to 2x all squared, minus 169 is 13 squared. So I have my a squared minus b squared form, which results in the factored form of 2x plus 13, 2x minus 13, a plus b times a minus b. Use your zero product property to set both of those factors equal to 0, creating mini equations that we know how to solve. It's a 2-step equation. I'm confident you can do this. Resulting in the two solutions, negative 13 over 2 and positive 13 over 2. We have one more example to go over. This one is already set equal to 0. But like I said before, I really don't like working with an x squared that's negative. So I'm going to take a GCF of negative 1 out to fix that situation. Negative 1, 5x squared plus 9x minus 2 is equal to 0. It's not a special case. A is equal to 5 and not 1. So factor by grouping it is. This time I need to multiply a times c. So I need to multiply to negative 10x squared. I need to add to the middle term, which is positive 9x. Two numbers that do that are negative 1x and positive 10x. I'm going to take those two side numbers and replace my middle term with it. So I get 5x squared minus 1x plus 10x minus 2. I group the first two terms. They have an x in common, leaving me with 5x minus 1. I group my second two terms. They have a 2 in common, a positive 2 in common, leaving me with 5x minus 1. I know I'm factoring by grouping correctly if my parentheses match. They do. So that's going to become my first factor, and the outsides become my second factor. Now that I have factored form in my quadratic, I can set each of these factors equal to 0 to create my mini equations to solve. Oops, I forgot my GCF. It would have been okay though. I get negative 1 is equal to 0. There's no variable in that GCF. It does not result in a solution for x. 5x minus 1 is equal to 0. And then my last factor set equal to 0 results in x equals negative 2 as one of my solutions. Proper math notation uses curly brackets and puts our two solutions, negative 2 and 1/5, in order.